Find the vertex of this function. Now there really are two different methods, and since this is a chapter review, we're going to review it both ways. Method number one is completing the square. Complete the square. Now to do this, I need to factor the -4 out of the first two terms. So g of x will equal -4 times x squared minus 5x, leave a blank, close parentheses, and slide that minus 17 over to the right. We would then cut the -5 in half to a -5/2, square it to a positive 25/4. But that really isn't a 25/4 because there's a -4 distributing to it. It really isn't positive, it's really negative, so we're going to have to add over here to compensate for what we've subtracted. And since the 4's cancel, that's really a 25, so we're going to have to add 25 over here at the right. So finishing this process off, we have x minus 5/2 squared, -4 in front, and combining these values at the right together, we have plus 8. And that tells us that our vertex is located at positive 5/2. We change the sign when we go from parentheses to the vertex, comma 8. Now for method number two, and I'm going to switch to a black pen here because that seems to be running out a little bit. Method number two is the vertex formula. And let's again write our equation here. G of x, whoops, I should write vertex formula, shouldn't I? G of x is equal to -4x squared plus 20x minus 17. Now, the x coordinate of our vertex will be -b over 2a, and that will be -20, that's our b, over 2 times -4. That will be -20 over -8, which reduces to 10/4, which reduces to 5/2. We then substitute that 5/2 into g. G of 5/2 is equal to -4 times 5/2 squared plus 20 times 5/2 minus 17, which will turn out to equal 8, and we will see our vertex of 5/2, 8 done by that second method. This next function you can tell is a parabola because we have a y equals x squared. We see that it's been shifted 2 to the left. It's been shifted 1 unit up, and because of the negative out in front, it is opening down. Opens down. And because of the 1/2, it has a vertical compression or a vertical smush, whatever you want to call it. So let's start by moving our vertex, which is normally at the origin. Let's move that left 2 and up 1. Bam. And instead of going down, basically I can treat that -1/2 as down 1/2 and over 1 each direction, because normally it goes over 1, down 1. It just doesn't go down as far this time, and so we have our graph looking like that, going through those 2 points. If you wanted to plot more points, we could have gone, instead of over 2, down 4, over 2, down 2. I guess it would go right through there at -2. So I just haven't done a very good job here. That one should go there. That one should go there. And ignore that inner curve because it was just a quick sketch.